Okay, greetings to all. This is Dr. M. Shakti Mohan, Associate Professor. So today we are going to discuss about the content of combinational circuit design, in particular with the priority encoder design. So we have already discussed about the multiplexer, demultiplexer, and encoder decoder concept. Okay, so this is a special unit of encoder design. So we'll discuss one by one with a content screen. Okay, so I hope you can see the content screen. So generally priority encoder is a type of encoder circuit. So that means it also contain 2 power n, sorry, 2 power n inputs and n inputs, right? So since it is a encoder circuit, this is the basic concept. And what is called priority encoder now? So it contains a specialized output called priority function and output level indicator. Okay, so there are two priority function will be there, that is x and y, and v also there. Okay, so x and y is the priority function, that is it will show the priority of the inputs, and v is the output level indicator. Okay, so we'll see one by one. Okay, so first the theoretical part. A priority encoder is a encoder circuit that includes the priority function. Okay, that includes the priority function. So generally what is priority function now? In priority encoder, if two or more inputs are equal to 1 at the same time, the input having the highest priority will take precedence. That is, it will give the output according to the priority of the input, right? So that is what that is the concept of priority encoder. So we'll enter into the truth table. See, you can see this is what the truth table of the priority encoder. Actually, this is the input, that is D naught. Okay, you can see D naught, D1, D2, and D3 is the input, and X and Y is the first two outputs, that is the priority outputs, and V is the third output, that is output level indicator. Okay, since in the input we have 4 bits with the help of 8421 combination, I am just to fill out the input, that is 00000001, otherwise 8081 4041 4041, that is in terms of vertical. So 0011 0011 and 0101, likewise I'm just mentioning, right? So now you can see the outputs, right? So outputs la, it is very simple. Okay, so you can consider this as a 2 and this as a 1. Okay, well, the x is considered as a 2 and y is considered as a 1. Okay, so first I'll tell the concept of x and y, and after that we'll move into the v, right? So in this input la, you can see, so d0, d1, d2, and d3. Okay, so the suffix value is the priority values. Okay, you can see, you can consider 0 here, you can consider 1 here, you can consider 2 here, you can consider 3 here. Okay, so now you can check the input, and according to the priority, you have to mention the output here. So it's very simple. Now you can see the first input. So all the inputs having 0. So that means there is no priority in this. So that is why I'm just mentioning the first output as a x and x, because there is no priority here. Okay, and after that it is very simple. Actually the next input is what? 0001. Okay, so in this which input having the highest priority now, you know that, so the one will be there here alone. Okay, so this one is responsible for 3. Okay, so 3 is the highest priority, so 3 means you have to mention 1 for here. Okay, so why 1 now? 2 plus 1 is equal to 3, so that is why I'm just mentioning here as a 1 1. Okay, next, so what is the next input? 0010. Okay, that means the 1 will be there here, and this one represents the priority as 2. Okay, so that means for 2 you have to mention the output. So for means, so 2 la 1 and 1 la 0. Okay, likewise you have to fill the truth table. It is very simple, right? It is very simple. For example, if the input is 1 0 0 0, means what is the priority? Actually 0 1 2 3. That means 0 is the priority, so that means 2 and 1 la no need to mention any 1. So that means 2 and 1 la 0 0 will be there, that is the xy is equal to 0 0. You can see. here 1000 the output is 00. So likewise you have to mention the outputs. So xy this is the concept, right? And for the week what is the concept now? You again you have to consider to the input side only. Okay, if any one of the input is 1 na, you have to mention 1 in the v. That's all, very very simple. Okay, so compared to x and y this is somewhat easy. Okay, if any one of the input is 1 na, you have to mention 1. Okay, so that means for the first input alone it will be 0, and for the remaining all inputs okay, it will be 1, because definitely any one of the 1 will be present in the remaining all the inputs, right? That is the concept. Okay, so once you completed the truth table, after that you have to make a k map for x and y and for v. Okay, so this is what the k map for x. Okay, so there are two mapping here, and this is what the k map for the y, again two mapping will be there. And for v this is the k map, that is actually 4 mapping will be there. Okay, so 481 mapping will be there. And if you simplify the k map now, you can get the answer as x is equal to d2 plus d3, and y is equal to d3 plus d1 into d2 bar, and v is equal to d0 plus d1 plus d2 plus d3. Okay, so once you completed the um, equation, so the next part is just a logic diagram. Okay, so you have to draw the logic diagram like this. Okay, so this is how you have to design the priority encoder circuit. So it's very simple compared to the remaining and all. Okay, in today's video we have discussed about the concept of priority encoder, and the inputs and outputs of priority encoder, that is d0, d1, d2 and d3 is the input, and x, y and v is the output. So for x and y you have to mention the output as a priority, and for week if any one of the input is 1 you have to mention as a 1, right? Okay, I hope you understand the content today. Thank you.